Hi, Algebra 1. So we're going to run through the page 43, 44, which was in the red book, or maybe you got the worksheet if you didn't have the red book. All right, so the first example, we have this graph that looks something like this. Okay, so they're given all of the information, the representation of the graph, and look at how ugly those tables are. So you have f and f of x, and you have total decimals in there. If you go to the top right, starts talking about the domain, and they say the domain is continuous, and then they're using x such that x, and they use this. You can just say, x such that x is real numbers. You don't have to get real fancy on the interval notation. All right, so let's take a look at the graph below on page 43. So we have this graph that looks like it does this. Okay, we have a handful of dots that are placed. So another representation of this, I'm not quite sure. Let's just look at the equation. Let's not worry about the story that came. So, so our recursive function, because it's going down and right, so if you look at your dots, this first dot up here is at the point 1 comma 12. It's right there. The second dot below that is at 3 comma 9. So if I go down 3, if I go down 3 and right 1, which is 3 over 1, or negative 3 over 1, so we are basically subtracting. So our recursive is like next minus 3. And if we wanted to figure out our equation, it looks like way up here, this point here was 0 comma 15. And then we have this. So take a look at this. This actually is the slope of a linear equation. This is the y-intercept. So our explicit function, being that we have 0 in place, we have f of x is equal to negative 3x plus 15. It's a little different to think about. The domain, so first off, it's continuous, okay, because it's a straight line that we've drawn. And then our domain would be x such that x is all real numbers. Okay, so that means I could have plugged anything in for x and gotten something out. And then type of function this is, and the difference. So our difference is going to be the minus 3, and that's what we do. And this is also linear because it makes a straight line. Okay, flip over to the back side. We have the graph on page 44 that they kind of, I'll just draw the dots in and we'll figure out where we can go from there. All right, so I know this right here is, looks to be about 0 comma 0.25. What do you think? You make that work on your, because the first line would have been half, so I'm about half of the first line. And then my next point here appears to be at 1 comma 1. All right, so we're definitely growing. So it's going upward, so it's geometric. So that means that a we have ourselves a growth factor. So if I made my table x and f at x, or n and f at n, doesn't matter. If I had 0.25 and that to 1, so let's think about this. 0.25, is that the same thing as 1/4? I believe so. So what would I have to multiply 1/4 by to get to 1? And the answer would be, if I multiplied by 4, 1/4 times 4 is 1. So this is our growth. We have the 0 thing. So our recursive function is going to be next times 4. And our explicit function is going to be f at n equals, so we have our first term, it's at 0, so I have 0.25. I have my growth factor of 4, and because it starts at 0, I can just use n, so that's my equation. This, because they are dots, is discrete. Okay, the dots weren't connected. And then the domain of that, because we have just solid dots that are taking place, I'd say, because we have fractions in there, I'd say they'd have, our domain can be rational numbers. So we go x such that x equals rational numbers. Again, take a look at the circle graphs I have around the room to get that language down, double check those. And then we have our equation, and then this has a growth factor of 4. Okay. All right, let's take a look at the one below. It talks about a bubblegum machine is filled with 500 candies. Each person puts money in, 10 candies come out. Okay, so let's do this. I bet you we can figure this out real quick. So if this is n and this is f at n, or we could have done b for bubblegum, right? So you fill the machine, it's got 500 candies. Each person that puts something into the machine, it gives out 10 candies. It keeps going. So we have the 0 term here. We're minusing 10. So another representation of this graph, if we had tried to graph it, might look something like this. And I'm not making the graph real good, but it forms a straight line. So we know that this is discrete data because you get 10 at a time. Our recursive function is going to be next minus 10. My explicit is going to be f at n is equal to negative 10. Because I have the 0 term, I can just put an n in there. I don't have to worry about the n minus 1, and then plus 500. And this is an arithmetic or linear. So its growth factor is minus 10, or common difference. And the last problem says one person has a secret that they tell 2 friends within an hour. Each of those 2 friends tells 2 more friends the next hour, who tell 2 more, and so on and so forth. This is a model for the number of people who learn the secret. So we have x and we have f at x. We have 0, 1, 1, 2, 2, 3, 4, 5. Okay, so times 2 all the way down. So that's 4, 8, 16, 32. Okay, the domain being that you're not telling a partial person has to be basically the natural numbers, x such that x equals the natural numbers. So again, look at the things on the wall all around the room with the circles. The natural numbers start with 1, and you go 1, 2, 3, 4, 5. And then this is discrete because you tell 2 people, and those 2 tell 2 people, and so on and so forth. So it's just dotted. And the difference is taking place. Actually, it's not different. Would have been geometric, which would be exponential. So you never asked for the equation, did it? Okay, so our type of function and the difference or growth factor. So the growth factor, so we'll call the growth factor GF, is times 2. That's all we have to do with that. Okay, so let's get to about page 122 in the yellow book. Some of you don't have the yellow book. I gave you the second version of it. It might be like a couple pages later. But the very top is problem number 6. And the top says, Talks about the bubblegum machine. Well, we just did that on the last assignment, so let's not worry about that. Um, but let's look at number 7. So this was on last time's homework. But number 7 says, the given function, a radioactive element, decays at a rate of 5% each year. Scientists begin with 40 grams of the element. The function is modeled for the given amount. Okay, so something that decays is decreasing. So 5%, what I'm going to do is I'm going to go 100% minus 5%. That's going to give me 95%. The reason I'm not adding it is because we are decaying, we are losing some. So this is going to be at 0.95. Okay, so the domain of this is going to be continuous. It's continuous because you're gradually losing a portion until you get to the 95% each year. And so our domain is going to be x such that x is, in this case, because we started with 40 grams, less than 40, where you'd have to say that x has to stop at 0 or something like that, because you're not going to get less than 0. Okay, so that's kind of a goofy way to think of the thing. So the type of function, this has to be geometric, which is exponential. All right, so our table, if we kind of talk about our table, we only have one value. So if we have n and we had f at n, when we start, we have 40, and then it decreases by 0.95 each year. Okay, so because we have the 0, 40, that's going to work great. Our equation, our recursive, is going to be next times 0.95. Our explicit is going to be f at n equals this that 40. This 0.95 goes in parentheses, and because I started at 0, I'm going to raise it to the n. And so this is our growth factor. Growth factor is the 0.95. Okay, let's take a look at number 8 on page 123. And I think we would have done this on the homework last night. So you can double check that, maybe write it in. And then number 9, I don't think we did on the homework, so we can do that. So up here is, looks like 0, 40. And we have this line that comes down. All right, so let's see if we can identify another point on that line. It looks like way down here, if you look, is that like 22,8? I was just looking at my line. I couldn't figure out an exact one, but that might be one. All right, so if this is at 0, 40, and I'm going down to 8, if I come down to 8, that's 32 in this direction. And then if I went over to there, I'm basically going from here, that went over 22. So it means I have a slope, and remember it's a vertical over the horizontal, of 32 over 22. And if you wanted to, you could actually do that on a calculator. So as you deal with a decimal amount, would probably be fine. So if I go 32 divided by 22, that comes out to roughly 1.45. Okay, so that's our slope. If I wanted to make a table, we would have n and f at n. And I know that I have the point 0, 40, and then I have the point 22, 8. And so basically, this has a slope of 1.45. Okay, so being that we don't have 1, 2, 3, 4, 5, and so on and so forth, it's just that's what it is. So I'm going to list my first term. I can just do n. So my explicit and my recursive. So my recursive is going to be next minus 1.45. And my explicit is going to be f at n is equal to our first term, which is 40, time, and because it's 0, n, I made a mistake, I went backwards, I'm sorry. Being this is my growth factor, I'm going to go 1.45, and it's negative, times n plus 40. That's my equation. So this is for our domain, we didn't talk about that yet. So this would have been continuous because it's a straight line that's drawn for us. So because it's continuous, it's going to be x such that x equals the real numbers. And then I have my equation, and this, we would have had a growth factor of this one of negative 1.45. Okay, so we're going to kind of go a little bit easy today. What we're going to work on, so I'm going to give you this worksheet. So you have the front and the back of this worksheet, and I want you to work together on it, and it's due at the end of the period. So make sure you are working on it, get it done. Okay? Hope you all have a nice weekend. I don't have an assignment to give you for over the weekend. Bye-bye.